Cruise ships, with their grand size and luxurious amenities, are marvels of modern engineering. Yet, despite the advancements in maritime technology, these floating resorts continue to rely on conventional fuel rather than nuclear power. Here's a detailed look at the reasons behind this choice. Accident risks. Nuclear power plants require rigorous safety measures to prevent accidents, which can be more challenging to ensure on a moving vessel exposed to various maritime conditions. The dynamic nature of the sea, combined with the complex operation of a nuclear reactor, raises the risk of incidents that could have catastrophic consequences. Security threats. Nuclear-powered ships could become prime targets for terrorism or piracy, posing significant security risks. The presence of nuclear material makes them a high-risk target compared to conventional ships, necessitating additional security measures and protocols that are not currently in place for cruise liners. High initial costs. Building a nuclear-powered ship involves substantial initial investment due to the complexity and safety requirements of nuclear reactors. The financial burden of constructing such ships is significantly higher than that of their conventionally fueled counterparts. Maintenance and operation costs. The ongoing costs for maintaining nuclear reactors are much higher than those for conventional fuel systems. This includes the need for specialized crew training, handling and disposal of nuclear waste, and regular safety inspections, which collectively add to the operational expenses. International regulations. Strict international regulations govern the use of nuclear technology, particularly in civilian contexts. These regulations include extensive safety and environmental protocols that are costly and complex to implement. Compliance with these regulations would require substantial adjustments and investments from cruise operators. Port restrictions. Many ports around the world have restrictions or outright bans on nuclear-powered vessels due to safety concerns. These restrictions limit the operational flexibility of cruise ships, as they would not be able to dock at a significant number of popular destinations. Negative public opinion. There is often significant public resistance to the idea of nuclear-powered vessels, stemming from fears of radiation leaks, nuclear accidents, and the long-term environmental impact of nuclear waste. These concerns can deter potential passengers, affecting the cruise industry's customer base. Brand image. Cruise companies aim to provide a relaxing and safe vacation experience. The association with nuclear technology could detract from this image, potentially reducing customer demand. The concept of vacationing on a nuclear-powered ship might not appeal to the general public seeking leisure and tranquility. Complex technology. Operating a nuclear reactor requires highly specialized knowledge and training. The cruise industry would need to invest heavily in recruiting and training personnel capable of managing nuclear technology, adding another layer of complexity to their operations. Space and design constraints. Integrating a nuclear reactor into a cruise ship design poses significant challenges. The reactor and its associated safety systems take up substantial space, which could reduce the available area for passenger amenities and services. This would impact the overall design and functionality of the ship, potentially compromising the passenger experience. In conclusion, while nuclear power offers advantages such as long intervals between refueling and potentially lower fuel costs over time, the combination of safety, economic, regulatory, and public perception issues makes it impractical for use in the cruise ship industry. Conventional fuels and newer, more efficient technologies continue to be the preferred choices for powering these majestic vessels.